Welcome to All This Math. This is Professor Parker. And today we are going to be talking about rectangular arrays and the distributive property. And also, if you notice, I have my I Am Overbrook hoodie on today. And this morning when I was about to throw this on, I read the label, I read the front, and I was thinking to myself that, maybe I shouldn't wear this no more because I don't teach at Overbrook High School anymore out in West Philly. But then I thought, even though I'm not currently teaching at Overbrook High School, I'm still Overbrook because Overbrook helped develop me as an educator. For 2 years I was there. Overbrook helped develop me as a black man, and also Overbrook definitely helped me to see that we definitely need independent educational outlets for black children, such as All This Math. We need that. We just need it. We need independent educational outlets and spaces for us to learn mathematics outside of the typical areas where mathematics may be typically taught. So I'm thankful for that experience at Overbrook. Even the challenges. I'm thankful for the challenges as well, because the challenges were very helpful. All right, now, getting into our lesson. Again, rectangular arrays and the distributive property. All right, so what we're going to do first, right, with letter A and letter B, is we're going to take this expression, right, and represent it as a rectangular array. All right, so we have 2, and this is very important because we need to know how to read these expressions verbally when we see them. We don't want to say 2 parentheses x plus 10 parentheses. We don't say that. We want to say 2 times the quantity and then whatever's inside the parentheses. So here we have 2 times the quantity x plus 10. 2 times the quantity x plus 10. Now I want to represent that as a rectangular array. So when I think of that, what I want to be thinking about is, what does a rectangle look like? And I also want to think about, how would I find the area of a rectangle, right? So check this out. Imagine you had a rectangle, right? And you know that the formula for the area of any rectangle is area equals length times width. All right, we can make that the length, and we can make that the width. So from here to here is the width, from here to here is the length, right? So we got length times width, okay? Now, check this formula out. This is something times something else. Isn't this something times something else? It is. We have 2 times x plus 10, the quantity x plus 10. So what if I thought of 2 as my length, and I thought of x plus 10 as my width? And then I tried to draw a rectangular array, right? So it would look like this. Make sure I got enough space. So if my length is 2, I'm going to label this with a 2, right? And then if my width is x plus 10, I'm going to label the width x. I'm not going to put a plus sign though. I'm going to break it up into 2 parts, right? Because I got 2 different terms. I got an x term and a 10 term. So I'm going to break this up like this. I'm going to make this piece x and this piece 10. And this is how I represent x plus 10. In terms of the rectangle, I got an x part and a 10 part. See here we had x plus 10. So if I looked at it, really that's x plus 10 if I wanted to put it together. All right? And that's how I represent my rectangular array. All right? That's how I draw it. Let's go back to it. We start out with 2 times the quantity x plus 10. 2 is like your length. X plus 10 is like your width. But that's all based on the formula for area of a rectangle. Area equals length times width. The length times the width, right? And then you got to just look at the expression and say, okay, well, what's my length? Which part of the expression is my length? In this case, the 2. Which part of the expression is my width? In this case, x plus 10. All right? So now here's the part where you want to actually find out what the area is. Now, when you think of a rectangular array, think of it as a multiplication table. Just think of it as a multiplication table. Imagine your teacher gave you a blank multiplication table template, right? Like the one in the back of your marble composition notebook, except imagine all the numbers weren't filled in. All you had was all the numbers on the left side, on the left row, and all the numbers across the top row, right? Or I should say the left column, and all the numbers across the top row, and every space inside was blank, right? Like I got on the All This Math website that you could like print out for practice whenever you need it, right? You would multiply those, right? So I got a 2 here and an x here. So I would do 2 times x. 2 times x is 2x. All right, that inside the array. And then I got a 2 here and a 10 here. I would do 2 times 10, which would give me 20, right? So that says that I could represent the area of this rectangle as 2x plus 20, all right? Because really what a rectangular array is meant to do is meant to like visually show you what's happening when you're using the distributive property, right? It's helpful, right? It's helpful to see things, right? Because you can learn the distributive property and just rock out with the numbers and the variables. You could do that. But it's also very helpful to be able to visualize pictures, right? Like you could be on Facebook and write a long post with no pictures, or you could go over to Instagram and see the pictures, Visualization is important, okay? So we got 2x and we got 20. So 2x plus 20 would be the area of this rectangular array, all right? And remember, it's all based on the area of a rectangle and length times width. Now, let's do the same thing for this expression. 3 times the quantity, 4b plus 12c plus 11. All right, let's do that. So let's do this. Let's draw a rectangle. And it doesn't really matter how large the rectangle is. I'm just randomly just drawing it that large, right? You could draw it even larger. You could draw it smaller, right? I want 3 to be my length because remember, I'm following the area formula. Area equals length times width, all right? So this 3 is going to be my length. My length is on the left side, right? So I'll put the 3 right there. Now, my width is going to be this part. But this part has 3 different terms in it. In the first example, the width had 2 different terms in it. So because in the first example, 2 different terms were here, I broke up the width into 2 sections. But now my width has 1, 2, 3. It's got 3 sections. It's got 3 terms. So I'm going to break it up into 3 sections. So I'm going to do this. 1, draw 2 lines. So now I got 1, 2, 3. All right. So again, I had 2 terms in my width. So I had 2 sections. Now I got 3 terms in my width. So now I got 3 sections. Okay. So now I'm going to label them. Before I wrote the X and the 10 on the bottom, but that's just because I ain't have a lot of space at the top. I prefer to write my terms on top. All right. And then I write 12C right here, and I write 11 over here. So this space right here is 4B. This space right here is 12C. This space right here is 11. Now, do I know what B is and do I know what C is? No, I don't. Do I care what they are right now? No, I don't. It doesn't matter because that's not what we're doing right now. We're just trying to find the area of this rectangular array. And we don't need to know what B and C are in order to do that. We can just represent it with an algebraic expression like the one we were given. So, again, think about a multiplication table, right? We need to do the multiplication. So 3 gets multiplied by 4b. 3 times 4b is 12b. So I write 12b in here. Then 3 times 12c. 3 times 12 is 36. So 3 times 12c is 36c. Write that in there. And then 3 times 11 is 33. So I write the 33 right there. Right? So this will be the area, this expression right here. 12b plus 36c plus 33 will be the area of this rectangular array. Right? And also, if you use the distributive property, which is basically what we just did, we just used the distributive property in order to multiply 3 times every term inside these parentheses. Okay? All right. So that's how you set up rectangular arrays. That's how we create rectangular arrays, and that's how we find the area of the rectangle. Now I'm going to go into just some straight up examples using the distributive property. So let me erase this. Write some examples down. All right. So let's do number 1. 3 times the quantity 2x minus 1. Number 2, we're going to have 7 times the quantity 4n minus 5m minus 2. We'll do another one. Number 3, we're going to have the quantity 8j minus 3l plus 9 times 6. So yeah, the outside term can be behind the parentheses or behind the quantity, or it can be in front. Usually it's in front, but even if it's behind it, like in number 3, we still do the problem the same way. And I'm going to show you that. All right. So then number 4, we can also distribute. We can also divide, is what I meant to say. 48p plus 24 divided by 6. And then number 5, we got 14g plus 22n divided by 1/2. And yeah, I'm going to throw some fractions in here because we need to know how to deal with fractions, right? Fractions are your friends. Don't be scared of fractions. All right, so let's take it from the top. Let's go to number 1. Now, the distributive property, right? Think about the word distribute. Distribute means to give out, right? And we should distribute things fairly and equitably, right? We shouldn't distribute to some and not to others, right? So this says 3 times the quantity 2x minus 1. It basically means that 3 needs to be multiplied by every term inside the parentheses. So that means I need to multiply 3 by 2x, right? And when I do that, that's going to give me 6x. But don't forget to multiply 3 by -1. A lot of people do that. A lot of people will multiply the outside term by the first term inside and neglect to multiply by the second term inside. Always remember to multiply by the second term or the third term or the fourth term inside the parentheses. Make sure everything that's in the parentheses gets multiplied by the term or the number that's outside the parentheses, because we want equal distribution. We don't want unequal distribution, kind of like how we have in Western society with unequal distribution, right? You want to be equal distributors, okay? So now, then we got 3 times -1. Remember, that's a negative. It's not a positive. That minus sign makes that a negative. So that gives you -3. So we end up with 6x minus 3. Another thing I want you to think about is that using the distributive property is the inverse or the opposite of factoring. Factoring by taking out a greatest common factor, right? Because if I was to factor this expression, 6x minus 3, I would get exactly what I started with. The greatest common factor is 3, and then I would have 2x minus 1 inside the parentheses. But that's another lesson for another day. Now, look at number 2. Now I have 3 terms in the parentheses instead of just 2, like in number 1. I'm still going to distribute equally. I'm going to give the 7 to the 4n. 7 times 4n, that's 28n. Then I'm going to give the 7 to the -5m. So that's -35m. Then I'm going to give the 7 to the -2, which is -14. And that's my final answer for number 2. That's how I use the distributive property, right? I multiply, distribute. I give the term outside to everything inside. That's how I distribute. That's how I use the distributive property, and that's how you can too. All right, now we go to number 3. Now, in this case, there's no number in front, or no number written in front. The number written is in the back. Never fear, you do the math the same way, right? That's one thing I want you to pay attention to, is that sometimes problems will be set up differently. They'll look different, but you still do the math the same way. I'm still going to multiply the 6 by the 8j, right? Which is going to give me 48j. I'm still going to multiply this -3l by 6, which is going to give me -18l. I'm still going to multiply this 9 by the 6, which is going to give me 54, right? That's the final answer for that one. 48j minus 18l plus 54, okay? Now, 2 more to go. We're almost done. Except these 2 are different because these are showing division. But remember, when you divide by a number, it's really still multiplication, because whenever you divide by a number, it's the same thing as multiplying by the reciprocal of that number. Dividing by a number is the same thing as multiplying by the reciprocal of that number. So dividing by 6 is the same thing as multiplying by 1/6, right? But it's just easier to just do the division and treat it that way. So 48p divided by 6 is 8p. And then 24 divided by 6 is 4, leaving us with 8p plus 4. 8p plus 4. Now, last but not least, we're dividing by a fraction. Now, again, dividing by a fraction is the same thing as multiplying by the reciprocal of that fraction. So the reciprocal of 1/2 is 2, because the reciprocal is when you take a fraction and turn it upside down, right? Think about bunk beds. Somebody sleep on the top bunk, somebody sleep on the bottom bunk. If y'all decide to switch places, that's a reciprocal, because now who was on the bottom is on the top now, and who was on the top is on the bottom now. That's a reciprocal. All right? Now, 14g divided by 1/2, that's the same thing as 14g times 2, right? Because 2 is the reciprocal of 1/2. So 14 times 2 I know is 28. So that means this is 28g. And then I do the same thing with 22n. 22n divided by 1/2 is the same thing as 22n times 2. So that's going to be 44n. And we are done. So this is how you use the distributive property. So whenever you see the distributive property, whenever you see a term outside of a quantity enclosed inside parentheses, automatically think distributive property. Okay? Think of the distributive property, right? That's what we need to think of. Okay? And make sure that you always multiply the outside term by everything inside the parentheses. Sometimes we get familiar and comfortable with the distributive property, and we forget to multiply by everything inside, right? We get into a rhythm, we start flowing, and we just multiply by the first term and then don't multiply by the second term. Or we multiply by the first 2 terms and we don't multiply by the third term. Make sure you multiply by every term inside the parentheses. All right? So, hope that was helpful. Hope you learned something new today. Please like the video. Please subscribe to the page and share the video. Tell some other people about it. All right? There's more content where this came from, and there will be more content put up going forward. Thank you for tuning in. Have a great day.